Alright, everyone. Hope you're doing well. I just want to remind to take out your table of contents and make sure writing in today's lesson long division, as well as the following days will be synthetic and remainder theorem. Make sure you also write your page numbers so you have that identified. And now into the notes. Long division. Please, you can pause the video and start writing in the setup as you see here. So long division is a term-based method to divide polynomials to ultimately solve for roots. Standard form, as high as like ax to the 5th power plus bx to the 4th power plus cx to the 3rd power plus dx to the squared plus e dx to the 1st power plus, we just have the constant c. What we notice here is that every degree lowers by 1. From 5, 4, 3, 2, 1, 0, it always decreases by 1. This will become important as the lesson progresses. Also, a quick reminder, 36 divided by 9 is 4. We're going to write it as 36 divided by 9 is 4. Whereas this is the quotient, which is the result of this dividing dynamic. This is the dividend we're dividing from. And this is the what's called divisor. All right. When we're doing long division, this is the setup we're going to be using. Another one is dividing terms of like bases. And this is where we have 6x to the 6th power divided by 3x squared. So again, we divide the coefficients. 6 divided by 3 is 2. And we subtract the exponents. 6 minus 2 is 4. So 6x 6th power divided by 3x squared is 2x to the 4th power. 12x to the 10th power divided by 4x to the 5th power. 12 divided by 4 is 3. 10 minus 5 is 5. Again, divide the quotient, divide the coefficients, subtract the exponents. And lastly, we always want to cancel out something with this lesson. So as a quick reminder, when we have two positives, in order for it to equal 0, we must subtract the 2. This is because they have the same signs and terms. Similarly, negative 6x squared and negative 6x squared, they also have the same signs and the same terms. So for it to equal 0, we must subtract. When it comes to 5x squared and negative 5x squared, although they have the same terms, they have opposite signs. And so for that to equal 0, we must add. Similarly, negative 6x squared and positive 6x squared, opposite sides, they must be added in order to result in 0. So this concludes that we subtract the same signs, like terms of the same signs, and we add opposite terms of the opposite signs. Again, of like terms. Same signs, subtract same signs, add opposite signs. And so now let's get into today's example. Find the quotient of 4x cubed minus x minus 12 and 2x minus 3. So because it is going to be a quotient, we're dealing with division. And we have right here is the dividend and the divisor. And so our first step is to rewrite the dividend if need a placeholder. So what is a placeholder? Well, we're going to look at my dividend, 4x cubed minus x minus 12. I know that the degrees has skipped x to the 2nd power, right? It goes 3 to 1. So I missed that x squared term. So when I rewrite it, it should be 4x cubed plus 0x squared minus x minus 12. Whereas 0x squared is my placeholder because now all the degrees from greatest to least goes from 3, 2, and 1. My second step is to set up long division. And so this is where I have my bracket. 4x cubed plus 0x squared minus x minus 12. And my divisor, 2x minus 3. I'm now going to divide the leading term of the dividend by the leading term of the divisor. Leading term of the dividend is 4x cubed. The leading term of the divisor is 2x. So on the side right here, 4x cubed divided by 2x. The exponent's 1, so it's 2x squared. That right there is my quotient, and I want them to be lined up so they match. Step 4 is to multiply the quotient by each term of the divisor. So 2x squared times 2x is 4x cubed, and 2x squared times negative 3 is negative 6x squared. And so once I multiply, my fifth step is to operate like terms. So I have 4x cubed and 4x cubed. They are both positive terms, and because they're both the same signs, I must subtract. So it cancels out to be 0. What I do to one setup, I do to the other. So 0 minus negative 6x, subtracting a negative. So I add 0 plus 6x squared is going to be 6x squared. And then I'm going to drop down the non-used terms. Drop down unused terms. And now step 6, repeat steps 3 to 5 until solved. So now I have 6x squared divided by 2x. 6 divided by 2 is going to be 3. And x squared divided by x to the first power is going to be x. So that quotient is positive 3x. Then step 4, multiply the divisor. 3x times 2x is 6x squared. 3x times negative 3 is negative 9x. Step 5, operate like terms. 6 and 6x, they are both positive. Same signs, I must subtract. When I do one, I do the other. This cancels out. Negative x, subtracting by negative 9x. Shows again negative, so I must add. Negative x plus 9x is 8x. And then drop down unused terms. Now my leading term is 8x. Divide that by 2x. 8 divided by 2 is 4. My x's cancel out. So that quotient is 4. And now multiply. 4 times 2x is 8x. 4 times negative 3 is negative 12. 8x is both positive. I must subtract. Therefore, I must subtract here too. And because these are also the same signs, they are also going to cancel out. And I'm left with 0, resulting in the quotient is 2x squared plus 3x plus 4. Boom. All right. And so the question then also becomes, what if the remainder was negative 5? The quotient, it would be 2x squared plus 3x plus 4 minus 5 over 2x minus 3. Notice how my negative is not in the numerator, is still just being operated. And if this was a positive 5, it will look like this. So please note the difference between when we have a remainder or not, and we'll have multiple problems with that as well. Ultimately, this is just another way to find roots, because a given polynomial is not factorable or not quadratic. And once it's all those things, we can then graph and find the function visually. So here are all the notes to have. Thank you very much, and have a great day.